Now we go to the second question in this type of series of questions, namely assertion and reasoning type. As is usual, there will be two statements, statement 1 and statement 2. Statement 1 says, indophenol gives a red solution in ethanol which turns blue on treatment with sodium hydroxide solution. The second statement says the formation of indophenol and change of color to blue on the addition of sodium hydroxide forms the basis of Lieberman's nitrous reaction. We discussed about the Lieberman's nitrous reaction. It's one of the characteristic reactions of phenol. So, statement 2, the second statement supports the first statement. Therefore, the choice is A. Both statements are correct, and statement 2 is supportive of, stands in support of the statement 1. Now, this is being explained by a series of few small reactions. When you start with a paranitrous of phenol gives rise to a form like this. From the OH group migrates to this, and when it reacts with one more molecule of phenol in sulfuric acid medium, this gives rise to a species which is known as indophenol. This is actually the indophenol is obtained in ethanol medium, in acid medium. Now, when it is treated with sodium hydroxide, this hydrogen, the phenolic hydroxy OH group, is being removed, and then it forms of O minus. O minus rearranges to give rise to this type of a quininoid structure. This is known as the phenol, this is known as the benzenoid structure, this is known as a quininoid structure. It changes over to the quininoid structure in alkaline medium, which is blue. Therefore, this indophenol is red in color, which on treatment with alkali, which gives rise to a blue colored substance which has this structure. This is actually referred as the Lieberman's nitrous reaction. Start with paranitrous of phenol, treat it with one more molecule of phenol in acid medium, gives rise to the indophenol, which on treatment, which is red in color. And this red in color, which on treatment with sodium hydroxide, gives rise to a blue coloration, which is characteristic or typical of what is known as the Lieberman's reaction of phenols.